resistors in parallel circuits. When we are using them, what's going to happen? This is the circuit which I am going to show you. Here is a circuit, and I'm going to place two resistors for the time being. There is the battery, which is having a voltage V, and I'm going to place, as I told you, I'm going to place two resistors here. One is here and one is here. Am I clear?
Yes.
This is R1, this is R2. If I place a voltmeter across this is going to read V2, right? And if I place a voltmeter across this is going to read V1. V1 is voltage across R1 and V2 is voltage across R2. Is that fine?
Yes.
Good. So if it is fine, if I'm going to rub this, I'm afraid the whole of the rectangle will be finished. Okay. So now do you remember something that in parallel circuits, what is remained fixed? Do you remember? PD remains constant, right? And current is split. Am I clear? So
Yes.
the current is coming from this side, I, when it reaches over there, it is split into two portions. One is I1 and one is I2. Is that okay? And again,
Yes.
when it comes over here, it becomes I. This is nothing over here, okay? There is no line over here. It means there is no path to travel from this place. Now, we know that since I is split, so can I write I is equals to I1 plus I2? Is that okay?
Yes.
And we know one more thing, that I is actually V over R. Is that okay?
Yes.
So can I write I1 is equals to V over R1
Yes.
and I2 is equals to V over R2. Is that fine?
Yes.
If I place these three values in this combination, so V over R is equals to V over R1 plus V over R2. Is that fine?
Yes.
Okay. So what I can do from the right side, can I take V as common? And we are left with 1 over R1 plus 1 over R2. Is that fine?
Yes.
This V and V cancelled out, so we are left with 1 over R is equals to 1 over R1 plus 1 over R2. This is the combination we are normally using in parallel circuits. Is that okay? Right?
Yes.
Okay. Now I would like to make it a bit simple, for you people. If I take LCM, what's going to happen? LCM is R1, R2, right? And this R2 goes over there, and this R1 goes over there, so it becomes R1 plus R2 over R1, R2. Is that okay?
Yes.
And this is equals to 1 over R, but we are looking for R. So if we shift it to the denominator, and similarly, if we shift the denominator to numerator and numerator to denominator, this will become R is equals to R1, R2 over R1 plus R2. Is that okay? So in short, we write this is equals to product over sum. Any confusion? Confused somewhere? Aiza bete, are you confused somewhere? So now we are discussing it with an example when R1 is 10 and R2 is 20. So if we use product over sum again, so it's 10 times 20 over 10 plus 20. So you see over here 200 over 30. So it becomes 6.67. Now you see over here, as we have done one relation in series circuit. So here you see 6.67 is smaller than 10 and smaller than 20. So we can conclude from here that the combined resistance in parallel circuits is smaller than each individual resistor. That means combined resistance in parallel circuits is smaller than each individual resistor. So instead of having any calculation, if the question comes in the MCQ, we'll look for the smallest value which is smaller than each one of them. But keep in mind this product of over sum is applicable to only two resistors. If you have more than two, then you have to do the LCM method or do something different method then. Thank you so much.